Hello, this is Mrs. Brown, and this is a brief overview of adding and subtracting rational expressions, and actually we're going to divide a little bit at the end as well. Okay, so just like regular fractions, we have to have a common denominator or we can't add or subtract. So if you look at my first couple of examples, these are the same denominator. So r plus 1 and r plus 1. So if I have a common denominator, I just add the numerators. So denominator stays the same because I'm just adding, and then I can't actually combine those two. So that's my final answer. Okay. When I look at this one, I already have a common denominator of x plus 2. Now be careful. Remember that when I'm subtracting, it's like you're distributing a negative. So since these are both positive, they're both going to become minus when I'm writing it out. So I'm going to rewrite this. This is going to be minus 2x minus 1. So be really careful because subtraction is where people tend to get tripped up. And then I just combine like terms because I can combine like terms. So 3x minus 2x is x, and 7 minus 1 is 6. So it's x plus 6 over x plus 2. Okay. If you look at this one, it's close to being common denominators, but it's actually not common denominators. If you look at this one right here, if I were to switch this around, it would be negative y plus 3, because the 3 is positive, then y is not. It's the opposite of this. This is a positive y and a negative 3. So if I factor out a negative 1, that becomes y minus 3, which is what I want. Well, then I have a negative and a negative. So what really is going on here? It's got minus, and then this is 3y minus y minus 3. Well, the minus minus becomes a plus sign. So my real problem is 4y over y minus 3 plus 3y over y minus 3. I factored out the negative 1 so that these would be a common denominator, and then I had a double negative, which makes it positive. So now I'm just going to add those together, and I get 7y over y minus 3. So sometimes if it's reversed like this, you just reverse it, factor out the negative 1, and then simplify if you have a double negative. If this is already a plus sign, then you're going to treat it like a subtraction problem instead. Okay? All right, least common multiple. Okay, this kind of looks a little bit funny. Like, remember least common multiple, if I had like 12 and say 8, it's the smallest number they both go into, which would be 24. So the least common multiple of 12 and 8 would be 24. So now I'm going to look at that with dealing with these crazy polynomials. So how do I do that? Well, the first thing I want to do is factor this into two binomials. Okay. So again, I'm looking for factors. They're both positive. So two things that multiply together to give you 4 that add to give you 5. It has to be 4 and 1. So it's n plus 1 and n plus 4. The n plus 1 squared, remember, is n plus 1 times n plus 1. So what I want to do is look for what's common in both, because I don't want to count that twice. So I have an n plus 1 here and an n plus 1 here. Okay. So the rule is whatever's in common, I only count once. So my least common multiple is going to have the n plus 1 in it. And then I am going to include what's not included. So n plus 1 and an n plus 4. So these I only counted once. And then I have an n plus 1 and an n plus 4 left over. So I can write n plus 1 as n plus 1 squared, because there's 2 of them, times n plus 4. And believe it or not, this is the least common multiple of those two. Okay, so again, what did I do? I factored it. I looked for what's in common, and I counted that once, and then everything I didn't circle, because I circled what was in common, I used. So I had to use another n plus 1 and an n plus 4. Okay? And I would do the same thing if I was doing prime factorization with just numbers. So it's kind of the same process, but it just looks a little bit different because we're dealing with all numbers. All right, so let's say I wanted to be able to add these together. Well, they do not have a common denominator. Dope. So what do? Well, basically, whatever this denominator is, I multiply here. Whatever this one is, I multiply here. So remember, if I'm going to multiply a fraction, I want to do it denominator and the numerator by the same thing. Okay, so I'm multiplying both of these in the first fraction by a plus 1. And I'm going to do times a for the second one. So the denominator, I'm going to just leave factored. I don't need to worry about it, but I can't combine the numerator unless I actually multiply these things out. So a times a is a squared. A times 1 is 1a, and 4 times a is 4a, so that's 5a. And then 4 times 1 is 4. If you need to write it out on the side instead, that's perfectly fine. For space and stuff, I was just kind of doing it a little bit in my head over there. A times a is a squared minus 3a, because it's a times minus 3 divided by a times a plus 1. Well, now you have common denominators, so you can add those together. A squared plus a squared is 2a squared. 5a minus 3a is 2a plus 4. The whole thing over a times a plus 1. And that would be the sum of these two rational expressions. If I have a complex fraction here, this complex where you have mixed number and the rational expression, I can't just put the 3 next to it. I'm trying to make a rational. So I actually, again, have to do a common denominator. This time, remember that any whole number can be made a fraction by putting it over 1. And so I'm going to multiply it by the other denominator over itself. Okay. And then I can add it to 4 over x plus 2. So this is obviously going to come out to x plus 2. 3 times x is 3x. 3 times 2 is 6. So that's going to be 3x. I can't combine with anything. And then 6 and 4 become 10. Okay. And that would be, again, dealing with, you've got basically a mixed expression. You've got a whole number and you've got a rational expression. How do you put them together? Again, whatever this denominator was, I was multiplying it because anything over itself is 1. I multiplied it, and then I have common denominators and I'm able to do it. Okay. Last, briefly, I want to just look at one complex fraction and how to deal with it. It looks scarier than it is. Really, remember, this is a division sign, so it's 12x squared divided by y divided by 2x divided by y squared. Let me switch markers. And so when I take a look at this, it goes back to how do you divide fractions? You keep it, change it, flip it. So you keep the first fraction, you change the sign, and you flip the second one. Well, now that you're here, you can simplify. Well, as you look, 2 goes into 12 6 times, and 2 goes into 2 once. X squared and x have a factor of x, so this becomes 1, and this is just going to cancel that out, so I'm left with 6x. Y and y squared, remember that y squared is y times y, so again, I'm taking out a y, so I get rid of that square, and that's going to become 1. And I end up with 6xy as my final answer there. Okay. Again, you can write it all out if you're a little bit iffy on that one. It's sometimes easier to write out x squared is x times x, and y squared is y times y. So that if I were looking at it that way, again, 2 goes into 12 6 times, 2 goes into 2 once. I can cross out an x, cross out an x. I can cross out a y, I can cross out a y, and when I'm all said and done, I'm left with 6xy. Okay, so if it's easier for you to think of it that way, you certainly can do that. I hope this helps, and have a fabulous day.